Hello. Hi. I'm going to start a minute earlier because so that we can finish a minute earlier. We have lunch after this, so just don't want to wait. Okay, so I'm Anupama and this is Jerry. We are going to talk about search at Reddit and how we made it relevant and how we scaled it to the level it is right now. Okay, it's not working. Okay, I'm just
Try again.
okay.
Try now. Okay,
Okay.
cool.
Okay, so I'm going to talk about what is Reddit, search architecture, and how we improved the relevance. And then Jerry is going to take over and talk about all the history of Reddit search and scaling our infrastructure. So what is Reddit? How many of you are aware of what Reddit is? Great, so I don't have to talk much. So we are a network of communities where everybody feels like they belong. People converse, people talk, we bring communities and belonging to everyone. We are the fifth largest site by Alexa, ranked by Alexa. We have 400 plus million monthly active users, 1 million plus communities growing every day, posts, comments, votes. But the searches are the important thing, the 68 million plus searches every day. So what are we doing with all that power? Okay, so cat fist bumping videos, dog getting pet love videos, but it's not just the cats and dog pictures, right? That's not what we want. So we are the communities, content, and individual. We want to focus on the authenticity, the freedom, the belongingness, and empathy. People find different things on Reddit. So in the subreddit called Our Assistance, one woman found her kidney donor. News source in the mass shooting at Orlando, the Charleston shooting, or the Paris bombing, Reddit was the biggest news source. Recently, we have discovered that people are actually turning to subreddit instead of traditional counseling. And these are the things people post about that I'm still alive thanks to this subreddit. And this is really something which is very, very important as a Reddit as a company also for people to find these things. But we can't find any of these if search doesn't work. So let's talk about the search part. Search is also important because we found that new users who search are 300% more likely to come back because they find the content. Also on mobile, more than 50% of all mobile users search a lot. So let's talk about search at Reddit. Of course, there is indexing and there is serving. We have all our data mostly in Postgres. We use Spark to generate the documents. We also have some modules which do natural language processing and high value term calculations, and then we index them into Solr. For serving, we have two main Solr cluster, and we also have the Solr Spark Analytics cluster, from where we get events of user clicks data into them, and then we have ranking models, and through search service, the snooze find what they are looking for. This is a little bit detailed diagram. We have a search VPC, use Zookeeper multi-zone cluster, Solr production. We also have Solr analytics, and again, the Reddit VPC, the Kafka is in different VPC, so there is multiple VPC to VPC talking, and we have multiple microservices. Again, this is more detail if you want to go over like what kind of infrastructure and tools we use. We use Puppet, we use Terraform, we have Hippo. We store our things in Vault. We use Cabo and Graphite for graphing and analytics. So nothing revolutionary, but this is all about the scale, which Jerry is going to talk about later. But this I'm just giving an overview of these things. Okay, so now we have all these things, but searching, subreddit search. Redditors are very creative. So when you say our Super Bowl, it's not about Super Bowl, but it's about Super Bowl pictures. How do you find this? This is like a funny thing. When I started using Reddit, I started using search, I was like, what? How can we do this? So we started using faceting on the post. So that gave us a much better result set. I mean, these are some things which were before and after for like coming out or like learning to code kind of things. But more interesting are like searches like iron deficiency. We never used to find anything before, but then we started finding out subreddits like Crohn's disease and baby bumps, because that's where things are getting used and people are talking about it. Same thing with oil leaking in the car talk, environment, motorcycles. These are the subreddits which people talk about all these data. Better post search. Post search is generally used phrase matching and self-test matching. But what about the images and link posts? So people will just post some LOL, look at this picture, and what is the picture about? So what to look at? So is the comments. But are all comments important and relevant? Because people will talk about something related to post in the top level comments, and then somebody will go and post a meme, and then there will be 100,000 comments related to that meme. So what is the comment which is most important? So the answer for that we found was the high value terms, which are the highest scoring TF-IDF terms from the comment section. So we started indexing those terms along with the post, self-text, and the titles, and we started getting much better results. It basically improved the recall for things for the self-text didn't match, and Redditors immediately started found we didn't even post about it, but they also always started commenting, is it me or has Reddit search incorporated machine learning recently? So Redditors are very, very receptive of all the changes. When Reddit search used to suck, they used to say all the time, Reddit search sucks. And now they say that, okay, it is becoming better, so it's a really good compliments for us. But we didn't stop there, of course. So, but this one gave us click-through rate higher by 3% and MRR by 4%, which is just search experience improvements for navigational searches because of the better recall. Next, we started improve search relevance by taking into consideration the user click signals. So we started aggregation results based on aggregated click signals and weighted them to boost the results which users are clicking on. So we used streaming events from Solr Fusion cluster, and then started using Spark jobs to do the aggregated data, and they used the output to boost the search results. And the results were really great. Like we got 12.5% increase in MRR and 7.5% increase in CTR. And this is in post search only. We got similar things for subreddit search. I mean, if you see the blue line, which is like constantly higher than the rest of the lines, we ran multiple experiments. So, we doing some roll-ups inside the code, outside the code. So we did much of but this shows like consistent improvement. We also launched some of the other experiments like head-tail analysis. So most of the 70% of the queries are the head queries, which are similar, but the tail queries, which are longer queries, which are smaller queries, have different tail reasons for why the queries belong in that area. So basically what we tried was like when there are multi-word queries, boosting certain terms in those queries to get better recall results. So for example, ADHD medicine, the medicine is a common word, but we'll boost the ADHD term. Or easily jealous is like, jealous is okay, but the easily part is like, more important. So we tried to use Fusion to give us these reasons and try to rewrite those queries and launch the experiments. And it gave us a much better recall for, long tail queries, which to find a better quality results. This is a little bit illegible right now, but if you get these slides, you will be able to see that. Basically, the goal was to get more recall into these things. We have all these things, but now we want to get to people to search, right? So how do we do that? So generally, Reddit can attribute their week DAU growth to different events or different movie launches or serial launches, Westworld launches, new Game of Thrones season launches, NFL, everything. Lot of users come, and we want them to search, right? So how do we tell them, to search? So we started launching this trending searches, like what were people searching yesterday and what grew. So we tell other people that, hey, this is trending in the Reddit search today, and then people will start clicking on it and getting more and more. And immediately, again, even before we put this into our announcements, people started noticing that, hey, this trending searches are great, and this is not in my face. So they really loved it. So like a couple of days ago, this was the trending today, the Nikki Haley Saints versus Redskins, and people are really enjoying this, and we are getting a lot more users getting into the Reddit to search to get their trending news and stories. Of course, we need to do NSFW categorization. There is a lot of content which is not safe for work on Reddit. But we want to figure out what content is safe for you right now. Like few months ago, Stormy Daniels was trending a lot, and that time she was not an NSFW search, but it was just a political news. So how do we look at that? So we look at the NSFW results in recall and look at how many people who are clicking on this content which is marked as NSFW. And we figure it out and dynamically show the results based on like whether they are belonging to NSFW or not. So certain queries, like as I said, Stormy Daniels is a really good example, whether should we show it or should we not show it, because is it NSFW or is it not NSFW? So that a lot of work went into this categorization and figuring out whether the content is there. Next, we started launching related searches because people are searching for X, they want to search for Y, Z, ABC, and we want them to, that grows into user retention and more time on the site. So we basically started looking into that. So of course, collaborative filtering is important. We have seen that Netflix and Amazon uses collaborative filtering, but in Reddit, we don't have too much user information. We try to keep users anonymous. So we have the post similarity, the search similarity. So we try to use the temporal proximity algorithm with co-occurrence counting and collaborative filtering for doing that. And the results which we got were really great. We also did dynamic temporal buckets as source of data. These are just more details about how we did it. Distinct queries in the session, intuitive, easily explainable. So and scales extremely well for building pluggable logic. The results are good. So if you search for learn, you'll see learn programming, learn Python, cat. We have cat pictures in subreddits called awe, and people want to search also for dog pictures, comics, kittens. But something funny was like something called blep. So blep and blem are very, very Reddity terms for some cat dog pictures. But if you search for blep, it will recommend you blem as a similar search because that's what people are looking for. This is all very, very Reddit focused. Reddit content is unique and Redditors are unique. So it's like, it's very different from a typical, search where if you are searching for iPad, you are also recommending iPad covers, whereas this is a little bit more unique to the Reddit culture. Okay, so we are doing a lot of future relevance work. We are doing contextual query understanding, how context informs query understanding, the seasonality, like what are users searching. It's an NFL season, it's an NBA season, it's baseball season. So how do we say that, what are users looking for? Understanding the user intent, classifying the query based on its interpretation, query rewriting, query tagging. So when the user is querying, basically figuring out the name entity recognition and then tagging it. Also, basic content tagging when you are showing the results, grouping them and showing them accordingly. So a lot of work is going on, but last year in this conference, our CTO and VP of engineering gave a keynote, which was just the beginning of user search. There's a lot of history which Jerry will go into a little bit detail, but we have come a long way in last 1 year thanks to all this work we have been doing. So next I'll give it to Jerry to talk about infrastructure and scaling and how we got here.
Hello, can everyone hear me? Cool. So Anupama talked about how we developed our relevance over the past year, and now I'm going to talk about how we took our infrastructure and we scaled it out to the 300 million users that we have every month to support the relevance initiatives that we are working on. So first I want to talk a little bit about Reddit search's history because Reddit search has a really interesting history. In the past 13 years, we've rewritten search about 5 times, starting with PostgreSQL search, and then moving on to Lucene, then Solr 1.3, and then we outsourced our search to Index Tank, which was then bought by LinkedIn. So then we moved from Index Tank into AWS Cloud Search, and surprisingly, Cloud Search was around the longest of all of our iterations for about 5 years. But then as Reddit continued to grow, Cloud Search started to become slower and not scalable. And our search uptime became so bad that eventually we had the opposite of 5 nines, which was 9 5s. And Reddit search had become such a widespread joke among Redditors, so wide that even our CEO, Steve Huffman, joked that he expected that search might work 10 years from now. So Redditors told us how much they love search. And when I say it became a joke among Redditors, it was like an excellent joke to farm karma with. So, example 1. Reddit search farm after a normal search request. And one of the quotes below I really liked is, this image should honestly replace the 503 all servers busy page by U7 of 11. And this next one is my favorite. And now a look at the machine that powers Reddit's search function. Ever since they moved away from Scotch tape, I've been able to get irrelevant results in record time. So a quick story about this particular thread, actually. One of the directors at Reddit at the time had posted that they were looking to hire search engineers. And I was browsing Reddit, not doing work wherever I was working. And I found the job posting, and I messaged him, and I said, look, Reddit's pretty cool. I'm kind of interested. And I actually got hired through this Reddit post, particularly. It's great to get hired by a shit post. So in 2017, we partnered with Lucidworks to rebuild search from the ground up. And the first thing we did was to bring our search infrastructure and stack back in-house. We split up a couple of AWS instances in US West with the necessary packages, installed Fusion and Solr, and then we set up each server's configuration. And so once we had begun ingesting data and initial relevance tuning, we're already starting to see major improvements in reliability and relevance. We went from needing 75 servers in cloud search down to only 24 in this new cluster. And several months later, we shipped this new search stack and infrastructure to GA, and things were looking really good. But when we needed to start scaling our cluster up, we ran into several issues. And the first issue we ran into was because we had set up everything manually, adding capacity to our cluster or changing our infrastructure meant manual work, and the more servers we needed to add, the more work hours it would take. Secondly, adding capacity to our cluster meant we had to rebalance our cluster so we could utilize the new capacity introduced. At the time, we were on Solr 7, which had introduced some basic auto-scaling features, but lacked policies to ensure a cluster was properly balanced, meaning that we had to rebalance a cluster by hand every single time we added machines. In addition, we had noticed that we had 150 milliseconds of cross-region latency due to the fact that our infrastructure at the beginning was in US West, while all of Reddit's infrastructure was in US East. And so because scaling up took many man-hours of effort, our team had to plan out our scale-ups to minimize the number of times we had to scale up in a year. So the first thing we set out to do was to improve our infrastructure by automating almost everything. And it was around that time that Terraform was gaining traction within Reddit, while Puppet was the tool of choice within Reddit to manage server configuration. And for those who don't know about Terraform and Puppet, Terraform is a tool for building, changing, and versioning infrastructure, and Puppet is a server configuration management tool. So what this means is we can use Terraform to set up our cluster and infrastructure, and then use Puppet to set up our server configurations. With Terraform and Puppet, we can programmatically make changes to infrastructure and server configuration really quickly. Ultimately, this meant less time spent on mundane tasks, less chance for human error, and more time spent focusing on making search better. Adding more machines to our cluster became a one-step process. And Terraform looks like this. You basically define how many machines you want, what AMI you want to use. You define the resources you want, so things such as how much of that, what instance type you use, security groups, user data, how much storage you want, and tags. And you write this all in code, and it's really easy to read and simple to set up and repeatable. So if I wanted to copy this to another zone, it's really easy to just copy paste. And so if we wanted to scale our server up from 20 servers to 21 servers, I just change one variable, ask for it to compute the plan, and we're done. So now that we're able to scale our Solr cluster with ease, the next item we had to tackle was make our cluster easier to scale through automated replica rebalancing in Solr. So our cluster runs in 3 availability zones in AWS, and availability zones are basically isolated AWS environments within regions which allow for fault tolerance. And one of the important ways we want to distribute our replicas is by availability zone, so that if any one of the availability zone replicas goes down, our search infrastructure can continue running without issue or user impact. And along that same line, we also want to ensure that no Solr machine contains more than one replica from the same shard. This is so that any one machine can fail at random without end user impact. And the next 2 ways we wanted to distribute our replicas has to do with balancing compute resources across machines. So let's say for our example cluster, we have 2 collections, subreddits and posts. Subreddits has one shard while posts has 2 shards, and each shard has 3 replicas. First, we want to make sure that each collection's replica is equally distributed amongst machines, which means that each machine should have either 0 or 1 subreddit replica, and each machine should have either 1 or 2 post replicas. And that kind of looks like this. And after we distribute each collection's replicas, we can see that there's actually an even better way to distribute our replicas. And that is to move the top 3 machines, the post replica from the top 3 machines to the bottom 3 machines so that each machine has an equal number of replicas. So you can see here the top 3 post replicas just moved down here, and each machine now has 2 replicas. And this leads to our final replica distribution rule, which is to equally distribute all replicas regardless of collection amongst the available machines. And there's a caveat here, though. For a perfectly balanced cluster, the load on each core has to be the same, which is not possible in a cluster with a wide variety of collections. So we do our best with just these 2 policies. And all these policies are easy to apply individually, but together they can be quite complicated. So we created an internal tool to help us rebalance our cluster with these rules in mind. And so the internal rebalancing tool that we created took each of our replica distribution policies and applied them in order, keeping track of each operation needed to get the cluster to a more balanced state. It then prompted the user with a list of operations to perform and confirms with the user each replica to move to ensure that not too many replicas are moved at once, and to allow for manual intervention in case a replica movement does fail. And this is kind of what the tool looks like. We basically tell it to rebalance, and it'll tell us what collection, what shard, what replica, and where we're moving it from and to. And then each prompt basically tells us, do you want to move it or not? And so once we did this, we also took the opportunity to move our infrastructure from AWS West to AWS East. And as a result, we were able to save 150 milliseconds of latency, which is 4x improvement. Which, when I saw this graph, at first I was like, this is the coolest thing I've ever seen. And I was really excited. So our cluster was now easily scaling, but we had a second issue that we constantly ran into, which was that reindexing our data took many, many weeks. In search, we have 2 ways to get data into our indices, through backfills and through streaming updates. Backfills are really useful when we need to add, remove, change our schemas, or the way we index fields, and streaming updates are good for keeping our indices up to date. And fast backfills are really important to us because they allow us to quickly iterate on document schemas, test new ways to analyze document fields, and fix data issues really rapidly. But before we get into indexing, I wanted to quickly go over our data model, which should shed some light as to why our indexing was taking so long. So at Reddit, we have something called the thing data model, which is used to store pretty much everything related to Reddit, subreddits, posts, comments, accounts. And they consist of 2 tables, the thing and the data table. One to store common parameters on each thing, such as deletion, upvotes, and downvotes, and another that acts as a key value store linking to the IDs in the table. So our first indexing framework used Hive. We pulled data from Postgres with Scoop into Hive and had a series of jobs and transformations to join these thing and data tables, rotate these keys into columns, and then store the final result as Parquet and S3. And Fusion Spark fetched these S3 files, indexed the data, and indexes data into Solr. And it looked like this, which is completely unreadable and crazy because there's about like 7 or 8 different layers in order to get to the final table, which is all the way up here. You can already see that this is super complicated, and we had a lot of issues with this indexing structure. First, it took several weeks to transform the data, which made us afraid of changing our schema. And the second was because there was so many transformation stages, it was really hard to debug and figure out how far upstream the data transformation issues were. We clearly needed a way more simpler way of transforming and indexing our data. And at that time, the Think service was being introduced, which was a service wrapped around our databases, meaning it was really easy to pull all the data we needed to index. So we decided to give that a shot. And so with the Think service, the search service could be used as a transformer and indexer of data, since code is much easier to read and write than HiveQL. It fetched the latest data from the Think service, transformed it into documents and into the documents we wanted, and sent them off into Solr to be indexed. And so one of the biggest benefits here was that the special logic in the thing service made it easier to handle certain Postgres data, such as the score of links, and converting the values in the key value store to actual data types, since data stored in the data table were all of type string. As a result, we were able to cut down our backfill time from multiple weeks to a single week with parallelization, and making changes to our schema wasn't so scary anymore. And it's even simpler, the architecture. We basically had data go into a Kafka or RabbitMQ queue. The search service would pull that data from the thing service and send it onwards to Solr. And so our second iteration was going smoothly until it wasn't. As our usage was the thing service was growing, we began to put too much load on the thing service, a service that other services began to use a lot. And we began affecting them, and several times came close to actually bringing Reddit.com down. In addition, other search initiatives began to highlight the slowness of our thing service indexing. We began to notice that our backfill times were scaling linearly with our data, which is never a good sign, and our backfill was growing to multiple weeks again. So we realized we probably shouldn't be relying on a live production service to service what should be offline data. And after conversations with our infrastructure team, they're like, well, what if you guys just have your own Postgres replicas? You guys can do whatever you want. If they went down, we won't care. And so we've begun to spun up our own Postgres replicas, and we started to use Spark. And so with Spark, we can pull directly from Postgres and transform the data into documents for indexing. One of the biggest benefits here was the ability to horizontally scale the number of Postgres instances we had and the number of machines we use for pulling and transforming data with Spark. It was so fast and parallelizable that we were a little worried that we would knock over the cluster with how quickly we can index data. So we throttled our backfills into Solr by repartitioning the data into a reasonable number of partitions that doesn't knock our Solr cluster over. And so with this indexing strategy, we were able to cut our backfill time significantly from multiple weeks to just days. All right, cool. So we have a scalable cluster. We got faster backfills. Nothing can go wrong, right? No. So we had one more issue that we ran into a lot, and that was we would get random 100% CPU spikes, firing alerts in the middle of the night, and then they would return back to normal shortly after. And at first, they were really infrequent, sometimes once a week, but eventually they got to a point where they would happen multiple times a day. And so we did some debugging and digging around, and we found that we were getting queries that would take multiple seconds to complete, sometimes 6 or 7 seconds. And it turns out those queries were high recall queries such as the, would, you, if, news, games, or this crazy query that one Redditor issued, where it's like AFD or CDU. I don't even know what the hell this guy was looking for. But because we were getting queries like this, they would take multiple seconds to complete, and they would block a significant number of CPU cycles in the cluster, ruining the search experience for others. So the solution was actually quite simple. We used time allowed in Solr config.xml. And what time allowed does is it limits query execution time to a specified number of milliseconds. And after those number of milliseconds have elapsed, the further computation is cut off and partial results are returned to the user. And so this query that we had before, I mean, we don't really care about relevance at this point, so we just serve whatever we want. If it gets bad results, then we don't want to ruin the experience for other people. A key thing to note here is that the time allowed is not a hard cutoff. So Solr continuously polls during the query execution phase to see how much time has elapsed since the query started. Only once it polls again and sees that exceeded the cutoff does it actually cut off the query. And this is the result of applying that time allowed change across the cluster. We instantly saw our CPU drives and our spikes basically disappeared overnight. So as you can see, we put a lot of investment and effort into making search better over the past year through relevance and through infrastructure and scalability. And some of the future things we want to do for scalability is have a multi-cluster Solr environment. The goal here is to have one cluster per collection so we can have hardware isolation between collections so that if one collection or machine is having issues and or goes down, it doesn't take down other collections with it. Another benefit to having multi-cluster, one collection per cluster environment is the ability to scale each collection independently to the hardware needs. A collection like subreddits doesn't have too much data, so you can use lesser grade hardware and machines, while a collection like posts needs much beefier hardware and way more machines. And lastly, with a multi-cluster Solr environment, we don't have to worry about balancing each collection. We can just ensure that each machine has an equal distribution of replicas, resulting in truly balanced clusters. Cool. So that's it for infrastructure scaling and relevance. Does anybody have any questions? Do you want to come back over? Person in the back.
So you mentioned that you use time allowed to cut off queries. So like what we have experienced generally is the time allowed kicks in when during the query evaluation phase. But once the query is actually issued on the Solr instance, the Solr instance can keep processing the query even if you cut it off and not return any result. So I'm wondering like what kind of experience you had with that issue of time.
So you're saying even after the time allowed it keeps going, it doesn't cut it off?
The Solr instance would keep processing the time allowed because the time allowed is not pushed down into the inverted index lookup phase. It's at the pre-processing and post-processing phase of Solr, at least in Solr.
Right. So I'm sorry. Could you say the question again?
So you said that you were seeing CPU spikes because of these expensive queries.
Yep.
And what you tried to do was use the time allowed. But even if you use the time allowed, say like 15 seconds or something, and cut off the query will return like a 500 or something back to the user or return partial results if you have it configured. But the Solr instance that is looking up the inverted index, which is experiencing the high CPU, would still continue processing that query. It wouldn't like stop processing the query once you executed the HTTP request to the Solr instance. So what I'm asking is like, what do you do like in your infrastructure? Like, how do you like account for that, or maybe you do something differently that does not encounter this problem?
I don't think we've ever. So the question is basically how do we deal with situations where time allowed is exceeded, but Solr continues processing the query on the machines? So we've actually never run into that issue. But I would say that the way we try and get around that, we did think about that, is to have a more aggressive time allowed, so that if you were to exceed the time allowed by like 50 milliseconds, it would still cut off within time to not take all your CPU cores. Does that make sense?
Okay. Yeah. I mean, generally, like if your query was taking a lot of time to process, which may actually be your case when you have like a query which is like A or B or C or D or something that you showed.
Mm-hmm.
So just the query evaluation phase, if you cut it off, maybe that saves the processing time that you invest in the query. Yeah, we can talk.
Yeah, let's chat afterwards.
What version of Fusion are you running, and what's your automated deployment strategy to update Fusion/Solr across your various clusters?
So we're running Fusion 3.1. We're actually running two different versions of Fusion. We're running Fusion 4 in our analytics cluster and Fusion 3.1.2 to serve search queries. Currently, we don't have a great way of updating Fusion. That's actually something I'm trying to work on, which is better improve the deployment of new versions. But with Solr, what we do is we use Puppet. And what Puppet does is when you change the version that you use on Puppet, Puppet will automatically download the new version and wait until your command to install this new version. And so we do a rolling. We have this tool called Ansible that goes through lots of different servers. And you can use Ansible to say, all right, install this new version and then restart Solr. And so it just does that automatically and does it on every machine except the overseer node, which should be the last one to get upgraded.
Are you leveraging signals?
Yes, we are leveraging signals. Yep.
So you have a strategy to export the signals and update Fusion. I think it's just a working.
Yeah, last time when we updated on the analytics cluster from Fusion 3 to 4, we had a lot of problems. So basically, we created a new cluster and moved everything onto that cluster rather than upgrading the version from 3 to 4. The path from upgrade to 3 to 4 was not straightforward at all.
we're challenged with that right now. So.
Yeah. So, yeah, even now we want to go to the newer version, and we are just, we wanted to create a new cluster and then just move our Kafka pipeline to, because the signals anyway we get cut off, so, it's okay to, do the step over to that cluster. So we are just creating a new cluster and then, killing the old cluster, because the Fusion upgrades are not easy.
Any other questions?
And we talked about in the beginning that you do this head tail analysis. So it's all dictionary based, or how do you know using machine learning to classify the objects?
Yeah, so Fusion, we use Fusion, Lucidworks Fusion. So that has an AI component which runs this job for head tail analysis, and that gives us a list of reasons for why this query is particularly in a bucket. So generally, figuring out head or tail queries is easy, but generally use functions to see what queries are frequently used and what queries are less frequently used, and then do a chart of which is generally like spreads across to show you those queries. But the reasonings are more detailed, and Fusion does a good job of figuring out why these tail queries are bucketed into different buckets, like whether it's like a spell check ones, and spell checks are basically based on recall size. Like if you are wrong spelling, then the recall is very low, or like these ones are the tail queries with multi-word terms are the ones which we launched the experiment for, because these are multiple words. So you can figure out like when people are searching with long tail queries, the recall generally becomes low because you generally try to do a phrase matching and then it stops. So that's why the boosting on certain words gives a better results.
Any other questions? All right.
Okay.
If not, thank you for coming, everybody. And
Thank
we are
you.
hiring, so if you're interested, come talk to us.